That's some good knowledge right there. All right, so we're going to go wrap up the slab and collect some data. First, though, I want to show you the size comparison of each gummy bear. So we're going to take every single one of them out there and just kind of let you see the size. So this is our control group, Mr. Green. The red one over here, the third one that had the salt, we're going to hopefully dig him out of there. Pour some liquid. See him right there. So he looks just a little smaller. And then here is Mr. Orange. Gotta be very careful with Mr. Orange because Mr. Orange has started to dissolve a bit in the water. So luckily, we can salvage him as much as possible. Woo, there we go. So as you can see, the size comparison of all three. So the control group, the normal water, and our salty one right here. So we're gonna weigh these here after a bit to see how much they changed in weight to determine what osmotic state they were in. Again, just another look at the size comparison close up so you can see them. All right, so now that we've got the gummy bears out of the beakers, we're going to put them on the scale to reweigh them. So we're going to use our control group first. I've already zeroed the scale, and we're going to see how much he weighs. He's actually at 2.22 grams, and his beginning weight was around 2.21 grams. So he went up a little bit, but that could be just an error in the scale for whatever reason. Okay, so we've got that one. All right, now we're going to try Mr. Red, which was the very salty solution. His beginning weight was 2.58 grams. His weight now is 1.72 grams. So he actually decreased in weight over time. Then the third and final one here, which is the regular water solution, which is Mr. Orange. His beginning weight was 2.55. His weight now is 4.81 grams. So he increased in weight over time. So there you go. All three of them have been reweighed, and that's what you need to add into your data table. All right, so to explain the lab and how it worked using osmosis, I've drawn out these diagrams to kind of help you out. Now remember, osmosis is the movement of water, okay? So in relation to the concentration of a solute. So a lot of times water can move across the membrane easily, but some of these solutes like sugar or salt or things like that are not as easily transmitted through the plasma membrane. So water a lot of times will move in and out of your cells, creating these osmotic states that you might see here. And we use the gummy bears to simulate some of those osmotic states as we discussed in the previous video. So as we look at the first one, we have a hypotonic state. I like to think of hypo as hypotonic state. So like a cell almost exploding because there's a higher concentration of solute on the inside of the cell. So the cell has taken in a number of things, materials, whatever it is, and then the water wants to level it out because on the outside of the cell, there is a lower concentration of solute. But that means there must be a higher concentration of water on the outside as compared to the inside. So the water will actually rush into the cell to try to equalize it out through the process of equilibrium and natural diffusion process. That can actually inflate the cell so much that it can actually burst, causing the cell to die, releasing its organelles and contents on the inside outward, okay? So that is not necessarily good for animals, okay? For us, our red blood cells, we do not want them in a hypotonic state always. For plants, they prefer a hypotonic state because they don't explode. They have a cell wall that actually prevents them from rupturing that plasma membrane. So the cell wall made of cellulose pushes back on it, and this is a happy state for plants. This would have been the case of our orange gummy bear. So Mr. Orange Gummy Bear, as we've seen, inflated. A lot of water went into him because he has a high sugar content on the inside, so the water rushed in, causing his body to swell far more than the other ones. All right. We didn't really have an isotonic state for the lab, but you could say maybe the control group, but again, we didn't subject him to any water flow, so it's really not an osmotic state. We could theoretically make a solution of salt and water to put the gummy bears in an isotonic state so that they actually don't increase in size or decrease in size. Okay, so this is just a natural process, and the water's flowing in, and as soon as water flows in, some flows out. Again, it's a natural process of diffusion because the concentration on the inside of the solute is the same on the outside. Okay, so this is a happy state for you. For plants, not so much, because this is when they become wilty. So plants like to have this turgid pressure in a hypotonic state. Isotonic is more for you, happiness there. Then you have the hypertonic state. Isotonic, yep. So hypertonic state, you would have the concentration is much higher on the outside, the solute. So the water concentration is much lower on the outside as compared to the inside. So water, through the process of osmosis, wants to flow from high to low. So the highest concentration of water is here. The lowest concentration of solute is here, but the water wants to move out. When doing so, it will actually flow out so much that the cell will actually shrivel up into almost nothing. Okay? So it's basically like the cells are dehydrated. And this is not a good state for you or plants. This could mean death for both of you. All right? So that's the different states of osmosis. Now, in the hypertonic state, this would be an example of our red gummy bear, the red gummy bear. He actually shrank in size over time because the concentration of sugar or of water was of salt was much higher on the outside, so the water inside the gummy bear actually went out to the contents around him, and he shrank in size, even though he was in water. We think gummy bears would dissolve in water, they do, but this one actually shrank because the concentration of osmosis.